system of equations, you normally get an equation in standard form like this. You have two constants that equal a constant, but those two constants are also multiplied by two variables. This is in standard form. So in order to solve an equation like this, to get x and y, you must follow the missing variables concept, which means if you have two missing variables, you are going to have two equations to satisfy both variables. So if you have three missing variables, you must have three equations. However, if you have three missing variables, what will end up happening is you'll eliminate one of the variables and solve it in standard form using two missing variables, and you'll plug it back in. So for system of equations like this, we have three different cases. We have independent and consistent cases, which means that they have different slopes, but they cross at a certain point on a graph. Then we have dependent and consistent system of equations, which means that they have the same slope and the same y-intercept, which means it's the same line, so both equations will equal the same line, meaning that there's an infinite amount of solutions. Inconsistency is when you have two parallel lines, and how you get two parallel lines is if they have the same slope and a different y-intercept. Now, since most of these are written in standard form, if we want to graph them easier and find their slopes and see whether they're independent and consistent, dependent, consistent, or inconsistent, we should rewrite them in slope-intercept form. Now, I'm going to show an example for each of these. So first, let's start with the independent and consistent. We have x plus y equals 2. And let's say we have 2x minus y equals 3. So this is written in standard form, and this is a system of equations, and yes, there are ways to solve it. However, that is in the next section. Right now we are just focusing mainly on the graphing portion of it, kind of seeing whether or not you can actually solve these, or how the solutions are going to end up. So let's convert each of these into slope-intercept form. So for x plus y equals 2, you want to isolate the y, so you'll subtract x from both sides. You will get y equals negative x plus 2. That's it. You have your y by itself, you have your slope, which is negative 1 over 1, and plus 2, which is your y-intercept. And for this one, you have 2x minus y equals 3. So you want to get the y by itself again. So you subtract 2x from both sides. You have negative y equals negative 2x plus 3. Then you want to divide the negative, which is just a negative 1. And you end up getting y equals 2x minus 3. So as you see, we've written them both in slope-intercept form. And what you see is that they have two different slopes and two different y variables and two different y-intercepts. So what that means is if you graph that out, you will find that the two lines cross each other at a certain point, which means that there's a certain solution that suits the two missing variables. Now, for the next example, we are going to do a dependent and consistent case. So if you have 2x minus 3y equals 1 and 4x minus 6y equals 2, easiest thing to do would be convert it to slope-intercept form. So you have 2x minus 3y equals 1. Isolate the y. Subtract 2x from both sides. You end up getting negative 3y equals negative 2x plus 1. And you also, so you want to isolate the y. Divide negative 3 by both sides. You get y equals positive 2/3. Sorry. Positive 2/3 x minus 1/3. And for the other equation, you have 4x minus 6y equals 2. So, again, isolate the y. Subtract 4x from both sides. You have a negative 6y equals negative 4x plus 2. Divide the negative 6 by both sides. You get y equals 2/3 x negative 1/3. So you end up getting the same slope and the same y-intercept, which means it's the same line. You will get an infinite amount of solutions no matter what you plug in. On that line, you will satisfy both of these equations the same. And for the final example, we are going to do consistent example. Say we have 2x minus 3y equals 1. And let's say we have 4x minus 6y equals 3. So let's convert it to slope-intercept form. So you have 2x minus 3y equals 1. Subtract the 2x from both sides. You get negative 3y equals negative 2x plus 1. You divide the negative 3 by both sides. You have y equals a positive 2/3 x minus 1/3. Now, for this one, you get 4x minus 6y equals 3. Same thing, slope-intercept form. Subtract the 4x. Negative 6y equals negative 4x plus 3. Divide the negative 6 by both sides. And you get y equals a positive 2/3 x minus a half. So the reason why this is inconsistent is because they have the same slope. So on a graph, yeah, they will exactly have the same line technically, but since they have different y values, they will never cross since they have the same slope, so they will always therefore be parallel. And these are just ways to see if the system of equations work or not. Next section, we'll be going over the different ways to solve these types of equations.
I'm going to be doing chapter 4.2, 3 methods of solving systems of linear equations. And the first method is going to be substitution. Substitution is when you solve for one of the variables. For example, let's solve for y in the first equation. So 3x. So you're going to subtract 3 onto the other side, leaving you with negative minus 3x. Divide by negative 2, leaving you y is equal to 10 minus 3 all over negative 2. Both of this cancels out and the negative cancels out, giving you y is equal to negative 5 plus 3 over 2x. Now that you have solved for the y, we're going to substitute the y into equation 2, meaning that we are going to take this and put it inside of the y right here. Now solve, so you're going to add this to that. So first multiply. Then add 5 to both sides and add these two together, leaving you 8 over 2x equal to 8. When that's simplified, it's 4x equal to 8. Divide the 4 over. X will be 2. Now that we've solved for x, we can plug it back into equation 1 to find y. So y is equal to negative 5 plus 3 over 2. And where the x is, we put the 2. So y is going to be equal to negative 5 plus 3. Y will equal negative 2. Your point is going to be 2, comma, negative 2. So that's solving by method of substitution. Next is elimination. So the goal of this method is to get two variables of the equation to cancel out, leaving you with one variable to solve. For example, here we're going to get rid of the x. So you multiply equation 2 by negative 2, leaving you with 2x. This is 1, this is going to be 2. So negative 2x plus negative 4y, negative 10. So these two now cancel out. This is going to give you negative y is equal to negative 2. Divide by negative 1 each side. Y will equal 2. In order to make variables cancel out properly, you have to plug it back into the equation here and solve for x. Now subtract 4 onto the other side, leaving you with x is equal to 1. So your point will be 1, comma 2. Finally, the last method that we're going to do is the graphing method. So when the lines intersect on the graph, the points are its solution. So there are 5 steps to this method, which I will explain using these two equations. So step 1 is something called the cover-up method. So for x, we're going to cover up y. So 3x equal to 4. X is going to be 4 over 3 when y is 0. Now cover up x, and y is going to be 1. Now the other problem, cover up x, y is going to be 0, 5. Cover up y, 2x is going to be 5 over 2, and 0. Step 2 is figuring out where the points intersect, so we have to graph them. So 0 and 1, 1/4, which is going to be right over here. And then 5 and 5/2. So step 2 is to locate where they intersect, which is right there. And then step 3 is pretty much you have to guess where the points, would be. Now my graph is a little bit off. However, knowing the answer, I'm going to guess 3.2 will equal x and 1.4 equal to y, although that is not accurate. Then step 4 is going to be making sure that these work with the numbers that you have guessed. So 3, 2, 4. So multiplying these two together, you're going to get 9.6 minus 5.6, which is equal to 4. And then the other equation, you will get, when you multiply this, you'll get 6.4 minus 1.4, which does equal to 5.
So in chapter 4.3, we're going to be solving system of inequalities. For example, if you start with it gives you 2 set of inequalities, and you have to solve them to find points, x and y. Okay, from there you have to change the inequalities to equalities, and to do that you just make them equal. After you're done changing them to equalities, you have to graph them. By graphing them, you just set x to 0 and y to 0, and then get your points. So after you make them into equalities, you have to find x and y. From there, you get your points. And after that, you just graph them. Okay, so after you have your points and you graph them on the piece of paper, you choose any point that, you can choose any point to see which ones, to see if it satisfies the inequality. After that, you just shade the area that it satisfies it. So in this case, we have 0, 0. It's the most easiest point to use. So you plug it into the equation to see if it satisfies both inequalities. So you see that 0 is less than 4, sorry. So you just shade this area. And then you see if the other one satisfies whatever, and it doesn't, so 0 is not greater than 5, so you shade the other area. And after that, you see that in this little area, it satisfies both inequalities. So the next exercise will be this problem right here. Like I said, you always have to make it equal to each other. So x minus 2y equals 4. From there, make x equal to 0. By doing so, you get your points. So for the first problem, you get your points for that one, and then for the next one, you do the same thing, set x equal to 0 and y equal to 0, and then you get your points. So as you can tell, they have the same points, so you can just do one graph. So after you graph your point, you choose any point inside the graph to see what side is the corresponding area for the graph. So for this one, I'm just gonna do 0, 0. So 0 minus 0 is greater than 4, and it's not, so you shade the other area. And as for the next one, you can do 0, 0 as well. 0 minus 0 is less than 12, which is correct, so you can shade the other area. So since this one doesn't have the equal sign. It's not part of the solution, which makes it no solution at all. So you can write no solution on the paper. And you're good. Just to make sure you guys got it right, we're going to show one more problem, okay? So we got 3x plus 2y is less than or equal to 11, and x minus 2y is greater than or equal to 10. So from there, you just make them equal. After that, you set x equal to 0 and y equal to 0. So and then after that, you just graph. Okay, so after you're done graphing it all and putting the points in the correct area, you find any point. Again, we can use 0, 0. So and 0 is less than 11, so that one is going to be right here. As for the other one, that doesn't apply, so, 10, sorry. It goes the other way. So you see that 0 is not greater than 10, so you shade the other part, and you see that this area is a satisfying area for both graphs.
To solve system of 3 linear equations with 3 unknowns, we have to first choose numbers for each equation. So this will be equation number 1, this will be equation number 2, and this will be equation number 3. We have to put these two equations together, or these two, and these two, or whatever it fits you. So for this, I will choose 1 and 2, equation number 1 and equation number 2 first. Then you have to choose which variable are you going to eliminate first. I will eliminate C because it's the easiest one. So with equation number 1, number 2, we have in here is x plus y plus c is equal to 2, and x plus 2y minus c is equal to 6. From here, I will add them up as this is a negative z, so we have 2x plus 3y, c cancels out, we have 8. From here we have equation number 4. So now I'm going to choose equation number 1 and equation number 3, and I will cancel out the same variable that I canceled for equation number 4. So we write them again. X plus y plus c is equal to 2. Equation number 3 is 2x plus y minus c is equal to 5. So we add them up again, and we have 3x plus 2y, c cancels out, equal to 7. From here we have equation number 5. So from here we put these two equations together to create a system of 2 equations with 2 unknowns. That is something that we already know how to solve. So we have 2x plus 3y equal 8, and 3x plus 2y equals 7. So in here we multiply this equation by -2 and this equation by 3. So we have the result. This is -4x minus -6y is equal to -16. In here we have 9x plus 6y is equal to 21. So we add this up and we end up with 5x, y cancels out, and we have equal to 5. X is equal to 1. We have our first variable in here. So we take this one and we plug it in any of these equations, number 4 or number 5. Let's plug it in number 4. So we have 2x plus 3y is equal to 8. 2, 1 plus 3y is equal to 8. We have 2 plus 3y is equal to 8. 3y is equal to 6, and y is equal to 2. We have now y in here. With x and y, we plug it in any of these three equations, number 1, number 2, and number 3. I'll do it in number 2. So we have x, that is 1, plus 2y, that is 2, minus z is equal to 6. So we have 1 plus 4 minus z is equal to 6. We have 5 minus z is equal to 6. Minus z is equal to 1. C, we multiply everything by a minus 1. Minus 1. And we know with y is equal to negative 1. C is equal to negative 1.
Hi guys, so today I'll be doing chapter 4.5, which was nonlinear systems of equations. So I'll be solving nonlinear systems of special forms, and as it was given in the handout, there were 3 different forms, and the first form left. So I'm gonna show all 3 of the forms and do one problem for each. So the first form was, let me write it down for you guys. It was ax plus by equals cxy. The second equation is dx plus ey equals fxy. Alright, so that's the first form. So now let's do a problem. Let's say we have 2x plus 3y equals 2.5xy. And let's say we have x plus y equals xy. So these are my equations. So what I'm gonna do is I'm gonna divide x and y from both the sides. So when I do it, what I get is 2 over y plus 3 over x equals 2.5. When I divide them, x and it cancels out, so it's going to be 2 over y. And then when I divide x and y from this, y and y cancels out, and I get 3 over x. So the same for this one. What I'll get is 1 over y plus 1 over x equals 1. Alright, so as I know, obviously I can't do it in this form. So what I'm going to do is I'm going to let 1 over x equals u. I'm going to let 1 over x equals u, and 1 over y equals v. After doing that, so 2 over y is going to be 2v, and 3 over x will be 3u equals 2.5, and 1 over y will be v, 1 over x will be u, v plus u equals 1. These are my new equations. Alright, so I'm gonna multiply the second equation by negative 2, and so negative 2 times v is negative 2 plus 2v, they cancel out. Negative 2 times u is negative 2u plus 3u will be u. Negative 2 times 1 is negative 2 plus 2.5 will be 0.5, so u is 0.5. Alright, now that I know what u is, I can find out v as well, so I'm going to plug back u into this equation. So v equals to 1 minus 0.5. v equals to 1 minus 0.5. Alright, so v is the same. v is also 0.5. So u was x, right? 1 over x equals to u, so u is 0.5. So x will be 2. X will be 2 because u was 1 over x. So we multiply, and was v equals 0.5. V was y, 1 over y. So 1 over y equals 0.5. When we cross multiply, what we get is what we get is 2. We get 2, y equals 2. Alright, to see if my values are correct, I'm going to plug x and y back into the original equations. So let's choose the first one. The first equation was 2x plus 3y equals 2.5xy. I know what x is. X is 2. So 2 times 2 plus 3y is 2 as well. 3 times 2 equals to 2.5 times 2 times 2. X and y, they're both 2. So 2 times 2 is 4, plus 3 times 2 is 6. 4 plus 6 is 10, equals to 2.5 times 2 is 5. 5 times 2 is 10. 10 equals to 10. So there we go, my equation's right. Alright, so I'm going to do form number 2 now. And form 2 is ax plus by equals c. Second equation is xy equals d. That's the second form. Alright, now let's do a problem. Let's say we have, for the first equation, we have 2x plus 3y equals 2. And we have, let's say, 6xy equals 1. That's my problem. Those are my equations. Alright, so the first thing I'm going to do is I'm going to solve for y. So let's take this equation. So it's going to be, so y will be y equals to 1 over 6x. I'm dividing 6 from both sides. So that's y. Now what I'm going to do is I'm going to plug y back into the first equation. So the first equation was 2x plus 3y. Y is 1 over 6x. 1 over 6x equals 2. Alright, so it will be 2x plus 3 times 1 is 3 over 6, and after simplifying it, it will be 1 over 2x equals 2. Now I'm going to multiply 2x to both sides. Alright, so what I'll get is 4x squared plus 1 equals 4x. I'm going to bring 4x to this side. 4x squared plus 1 minus 4x equals 0. Alright, now I'm going to factor it, and at factoring what I'll get is 4x minus 2 squared equals 0. Now I'm going to solve for x. So the square cancels out, obviously. So it will be 4x minus 2 equals 0. X equals to 2 divided by 4. X is going to be half, 1 over 2. Alright, so now that I know what x is, I can find out y as well. So I'm going to plug this back into one of these equations. So let's plug this back into the easier equation, which is 6xy equals 1. So 6xy equals 1. I know what x is. X is half. So 6 times half times y equals 1. 6 times half is 3y equals 1. And so y is going to be 1 over 3. Alright, so those are the values. Alright, so now I'm going to do the last form, which is form 3. These are all pretty easy actually. Alright, so the form is xy to the n power equals c, and xy m equals d. So those are my two equations, and let's do a problem now. Alright, so let's say we have xy to the 5th power equals 1 over 8, and second equation will be, let's say we have xy cubed equals 1 over 2. So those are my two equations. What I'm going to do is I'm going to divide these. When I divide them, x cancels out, and since y is the same base, so we can subtract the exponents 5 minus 3. So y to the y 5 minus 3 equals 1 over 8 over 1 over 2 will be 2 over 8. Will be 2 over 8 because I multiply to the reciprocal. So what I get is 2 over 8. So 5 minus 3 is y squared equals 1/4. And now I'm going to take the square root both the sides, and what I'll get is y equals 1 over 2. So that's y. Now that I know what y is, I can find out x as well. I'm going to plug back y into this equation, which is xy cubed equals 1 over 2. So y is half, so x 1 over 2 cubed equals 1 over 2. 1 over 2 cubed would be 1/8. So 1/8 x equals 1 over 2. So I'm going to divide 1/8 to from both the sides. X will be 1 over 2 divided by 1 over 8. X is going to be, so 1 over 2 times 8 over 1. This dividing, I'm multiplying the reciprocal. So x is going to be 8 over 2, and x is 4. There you go. Those are my two values. Now to see if my equation, if my values are correct, I'm going to plug x and y back into one of these equations. Let's choose the first one. Let's do the second one actually. Xy cubed equals 1 over 2. I know what x is. X is 4. Y is half cubed equals 1 over 2. So 4 times 1 over 8 equals 1 over 2. So it's going to be 4 over 8 equals 1 over 2. 4 over 8, once we simplify it, it's 1 over 2, so half equals half. So my answer was right.